For the longest time, a 3D printer has been my only means of precision manufacturing. So as I'm sure you can imagine, when it comes to a project as ambitious as, building an engine, my options are very limited. I thought about casting parts in metal. However, I don't own a forge. But all of that changed once I finally got a lathe, because this thing has opened up a whole new world of possibilities, one of which being an idea that I've had for a very long time. I want to know if it's possible to turn a scrap piece of steel into a cylinder for an engine. And by scrap, I mean one from the hardware store. So, here's the plan. I'm thinking that I can just bore out the inside of this pipe, so then I can use it to make a cylinder. And originally, I wanted to use this piston for the project, because it's a little bit wider than the inside of the pipe. However, there's already a problem.
Hello!
As it turns out, the pipe that I was just expecting to be closer to 1.5 inches is more like 1 3/5. Which means that I'll need a larger piston. But the only pistons that I could get my hands on that would, actually arrive on time, are made for 2-stroke engines. Alright, look, I know that it hasn't even been like 2 minutes and I'm already thinking of committing a heinous act. But just hear me out. Because the 2-stroke piston is lacking the oil control ring that's found on the 4-stroke piston, I'm thinking that as long as there's both oil inside the engine and mixed in with the fuel, then this should work just fine. Besides, this is going to be more of an experiment than anything, as the only thing I've ever made on a lathe was half of this hammer like 4 years ago in the 10th grade. So, trying to make an engine as my first real lathe project sounds like a bad idea.
Ow.
But there's only one way to find out. Bruh. Alright, so here's what we're looking at. So because the piston has a diameter of 43.96 millimeters, I determined that the inner bore is going to have a final diameter of 44.09 millimeters, or somewhere around that ballpark. And even after boring out the pipe, we should still have a wall thickness of around 2.2 millimeters, so nice! At first, I wasn't exactly sure how I should approach this, so I just cut off some of the pipe to throw into the lathe. But because the pipe is so large, the only way I can fit it into the chuck is if I swap out these interior jaws for a set of these exterior jaws. And I didn't realize that this would complicate things further. These jaws don't really have a good purchase on the pipe, and because the pipe is sticking out so far, it just keeps flying out of the chuck, which is really annoying. So I turned down the side of the pipe that I wasn't using, and now it fits in the chuck. Alright, so now that the exterior is all cleaned up and everything looks good, I can now switch to the boring bar to form the cylinder. It sounds really bad, and it looks even worse too. It's probably because the tool is sticking out so far, which is causing it to vibrate and chatter. So I tried a few different things, like removing this giant seam weld with a hand file. And I even tried using a thicker tool holder to try and make it more rigid. But no matter what feed rate I try, it just keeps chattering, and has totally ruined this pipe. For whatever reason, I decided to try again. If I mess this up once again, I'm just going to become a Minecraft YouTuber, I think. I'm not really sure what I was expecting, but clearly this isn't going to work. So, here's the new idea. I cut off a shorter pipe because instead of trying to bore through the entire length of the pipe in a single pass, I'm going to try boring the pipe on one side first and then flip it around. And would you look at that? Focus, bitch. You know what? That's not bad at all. Now that the setup is actually working properly, I finished boring out the first half of the pipe, and then I turned the pipe around to finish the other side. And once I was finished, the cylinder looked really good. And I was pretty happy with how everything turned out. But just before I get ahead of myself and start turning this into a cylinder, I need to make sure that the bore size is correct. And lo and behold, that's a problem. I made it way too big. And maybe that's what I get for just blindly following this dial without ever once checking its accuracy. Truth be told, I thought about just using this cylinder anyways, since the requirements for a running engine are surprisingly low. However, if we check the clearance gap, yeah, this is not gonna work. Since I'm already here, I decided it was better just to start over and do it properly. The bore size is perfect, which is great because I'm running out of pipe. Although there is this small groove that formed around the middle of the pipe as a result of the cutting tool stopping on the same spot over and over, but since it's far enough down that the rings won't run over it, it shouldn't be a big deal. So now that I have a usable cylinder, next I need to hone the bore. And to do this, I'm going to use this cheap tool that I got online, as it has these 3 stones that spring outwards to scrape against the bore. And to keep these stones lubricated, I'm going to use this mineral oil that's been in the background of like all my videos. The whole point of cylinder honing is to scrape a crosshatch pattern into the bore. These hatches form trenches that the oil gets trapped in, which not only keeps the rings lubricated, but the trapped oil also helps to make a better seal. And you know, I've never honed a cylinder before, so I tried a few different techniques for around 10 minutes or so, and it seemed like it was working well.
That's nice. I like that.
But I think my angle is too aggressive. Ideally, the angle of the crosshatch is supposed to be somewhere between 35 to 45 degrees, and this looks more like 10 maybe. But because these cheap stones have basically disintegrated, I entertained the idea of replacing the stones with bits of 220 grit sandpaper. And you know, it actually kinda works.
Hey, that actually kinda works.
Except of course that the finish is way too smooth, and the paper clogs immediately. So I ended up caving and just getting the replacement stones. And now it looks good. However, it was only until after I finished the hone that I started to realize something. So, I messed up. Now when I was designing this, I had the intentions of welding a plate to the top and the bottom so I could mount this to the block and the engine head. However, it has now occurred to me that if I try to weld anything to this, it is immediately going to warp it out of round and make it useless. After realizing this, I wasn't really sure what I should do next. I brainstormed a few ideas, until eventually I came up with a genius plan. This new one is practically identical to the last one, but instead of boring the pipe out first, I cut off some pieces of flat bar that I used to make the top and bottom of the cylinder. And after welding it all together, I bored it out on the lathe, and then gave it a good hone. Which, might I say, is probably my best one yet. And to finish the mating surface on the top, I used some JB Weld to pack all the cavities full before I faced it on the lathe. I wouldn't say it's a great finish, but I'll take what I can get. And while that completes the cylinder, that still doesn't account for everything else I need to do. Because if I'm going to be reusing the parts that were provided to me in the last video, that introduces some new problems. And if you also want to have fun with metal 3D printing, then you should check out PCBWay, as they offer not only that, but they also offer everything from 3D printing to PCB fabrication. And when you sign up, you get a free $5 welcome bonus, so definitely check them out. Anyways, because the bore of the new cylinder is a lot larger, the sealing face on the engine head isn't wide enough to cover the top of the cylinder, which means I'll have to resurface it. And because I only have a 3-jaw chuck, I thought I could just weld a small pipe to the top of the head, which then allowed me to fit it in the lathe. But that's not the only thing, because I also decided that I'm not going to be using this carburetor. You know, the one that I stole from a weed trimmer. Instead, I'm going to switch to using this larger one, as it's not only gravity fed, but it's also going to be much easier to dial in properly. So I cut off the old mount for the intake, made this new one on the lathe, welded it to the side of the head, and then I tapped on the new adapter. But since the new cylinder is a lot taller, and I'm also using a totally different piston as well, it means that I'll need a new crankshaft. So using this drawing that I made as a reference, I grabbed some parts from my scraps bin, and then got to work. So once the shaft was turned down to size, I started cutting up this piece of square bar that I'll use to form the crank webs. And when everything seemed like it was coming along nicely, I then bored out some pieces of round bar, then welded everything together to form the connecting rod. And unlike last time, where I sorta just guessed how heavy the counterweights need to be, I did some calculations and determined that I would need around 8 of these steel balls to keep everything in balance. Alright, and now that the crankshaft is finished, it looks really bad. Which seems to be a bit of a trend throughout this video, but anyways, all that was left to do was to print a new engine block. But while the block was printing, I thought of something. One of the biggest drawbacks of using plastic is that no matter how hard you try, once it gets exposed to oil, it never comes out.
Oh, shit.
Even on the old engine, which has sat on my shelf for almost like 3 months now, it still feels oily, which is not only annoying, but it's also causing the oil to sort of osmosis its way into the block. But what if I could just coat it in something to protect it from the oil? Like for instance, with some of this clear coat. I mean, on the back it says it's alright.
Okay.
So, I decided to conduct a bit of an experiment. And once it had finished drying, and my vision returned to normal, I was pretty happy with what I saw. After I covered the side of it with oil, I was able to easily wipe it off after, revealing a perfectly dry surface underneath. So, satisfied with my results, I then coated the rest of the block. And once it was dry, I could then finally put everything together.
Oh, that's so gonna break.
Trying to install the piston rings has me feeling like I'm walking on eggshells.
You know how to install rings without breaking them.
This is hard.
Because from past experiences, if you bend the ring just a little too much, it breaks it.
Oh, that's so gonna break if I pull on that any harder. How do... This is dumb. How do I can't get it. Please. Fuck. Yeah. No, it's tight.
Hell yeah. After the rings were installed, the rest of the assembly was a total cakewalk. You know, it's really nice when assembling something and finding that all your measurements were correct, so everything fits nicely together. For the most part, anyways. And to make sure the bore stays lubricated, I'm going to be running the engine on a mixed fuel ratio.
Ugh.
A ratio that I just kinda guessed.
That's really a lot.
It's better than nothing, anyways. And because the carburetor's gravity fed, I made this really sketchy kind of IV drip bag fuel system from a water bottle and a jack stand. So that way, the fuel level always stays above the float bowl. But I mean, after that, that's really it. All it needs now is some oil, and it's ready to test. Except for this first test, I'm actually not going to be feeding it any fuel, as I have no idea what could happen.
It split the case right in half. Oh!
Who could have ever guessed that my engine, partially made from plastic, would explode? Well, not me, because in previous attempts, nothing like this had ever happened, so I was actually really surprised.
The crankshaft is still on the flywheel.
I was still confused as to how it even exploded in the first place, but then I started to suspect that the ignition timing was set way too early, causing the piston to try and fire back downwards, tearing the block in half. But after I spent like the next 2 days rebuilding the engine, even with a much stronger block and also retarding the timing, it barely ran for like a minute until it too blew up again. Interestingly enough, the engine failed in a very similar way to the first time, and I honestly don't know how I didn't see this sooner. You see, while the engine is running, it's trying to force the block apart, which is normal. But having just 4 screws on the outer edges clamping to a thin portion of the block is clearly not enough. Now I could make the top part thicker so that there's more material offering support, but then I thought, what if I were to have studs that run from the base of the cylinder all the way to the bottom side of the block? That way, the forces responsible for tearing the block in half will instead be dealt with by the studs. So, I made some changes to the CAD design, reprinted a new block, then went through all the same motions until I had them finished. But annoyingly, I didn't have anything long enough that I could use for the studs. So I ended up not only making my own from some really thick wire, but I also had to make my own nuts for them as well. But I mean, that's what machining is all about, right? Oh, and I also decided it was a good idea to remake the connecting rod. So this time, 2 bearings can be pressed into the bottom end, which will bear the load. Anyways, I got it all put back together, and with a little bit of convincing, it fired right up.
So it has an oil leak, apparently. That's kind of gross.
I'm actually really impressed. It's able to maintain a decently high engine speed without any hiccups. Well, mostly, anyways.
Bye-bye. Look at all the smoke. It's vaping. Oh, it's just the key flew out.
But in no time, it was right back in service.
Oh, that's not going in.
You know, I wouldn't say that I trust putting my face right next to this thing, but it's actually surprisingly refined. And after playing with it for a while, I only think that it's right if we hear how it sounds without any exhaust pipe.
I bet it's gonna look sick if I take the exhaust off. Oh my god, that is so loud. That is so loud. Okay, I think I need to evacuate the scene for a minute here.
Okay, but seriously though, I've been promising since the beginning of this project that I'd find a way to fix the fuel issue, so that way it doesn't have to run off of propane and starter fluid. And this requires me to tune the carburetor. So the next day, after I fixed the output shaft that I totally didn't break...
Does somebody want to tell me what's wrong here?
I played around with the fuel screw to try and see what it likes. Until eventually, this happened. For the very first time, this engine is actually running on gas. Or petrol, same thing. Although it does hold idle, it seems like it still bogs down when I give it a bit of throttle. Maybe it's not warm enough, but more than likely it's still an issue with how the fuel is being delivered. But now that the engine is actually running, I want to take this as an opportunity to try a few tests with it.
Alright, so I'm going to be doing a brake dynamometer test with my bare hands on the flywheel. I don't know. That's actually got quite a bit of torque. Do a bit of hand start with it, maybe?
Admittedly, it's not the smartest thing. But even at idle, there's still a lot of energy stored in this flywheel, and it seems like it's able to pick itself back up after being loaded down. Now don't get me wrong, I'm really happy with this thing, but I think for the ultimate send-off, it's worth seeing just how long it can run before anything bad happens.
Turn on the old phone camera here. Dude, the Samsung camera's like the worst. Come on, you can do it. It's gonna blow up on my hands or something. Cool.
Alright, so it seems like it's having some trouble running.
My intake is melting.
So I decided to give it a quick break and let it cool down for a while.
Alright, so I'm dying at age 30. Alright, I think we all just want to see this thing run till failure at this point. Sick.
However, now it seems like it's struggling to hold idle. I decided to keep trying, but ultimately, the engine has had enough.
Yeah, I think that's all she wrote.
The engine head has gotten so hot that it started to warp the top part as if it was on a giant hot plate, so now it doesn't want to stay on. On the bright side, however, the engine still feels like it has plenty more to give.
Beat that one, Chrysler.
So, as per tradition around here, I decided to have a look on the inside.
Alright, moment of truth. Yoink. Whoa, it actually looks good. That's a first.
You can even see that the cross-hatching is still visible, meaning it was doing a pretty good job in retaining oil.
It's even ran long enough that it's started to develop its own carbon deposits. That is sick.
What impresses me the most is just how well it's held up after all that runtime, which also includes all the time it was running that you haven't seen, as I spent an entire day just firing this thing up over and over again to try and get a cool thumbnail photo. And it still looks serviceable. And if you want to see me make more engines, then subscribe, and I will do that. But anyways, that's it for today. Peace, guys.
I'm tired.